Hello friends, welcome to the T.Y.B.Sc distribution theory class. In today's lecture, we will see the interrelationship between gamma distribution and beta distribution. So friends, this relationship we will see through the example. So first example or first relationship is, suppose we have given that x has a gamma distributions with parameters alpha and lambda 1 and y has a gamma distribution with parameters alpha and lambda 2 where x and y are independent. This is the given information. Okay, now we want to find the distribution of here we want to find the distribution of u where u is a x upon x plus y. Okay, so firstly we will see the given information. So what is the given information? We have given that x has a gamma distribution with parameters alpha and lambda 1. Okay, so density function of 8 is f of x is equal to alpha raised to lambda 1 upon gamma lambda 1 e raised to minus alpha x raised to lambda 1 minus 1 where x greater than 0 and parameters alpha lambda 1 should be positive, 0 otherwise. Okay, this is the PDF of x. Now further we have given that y has a gamma distribution with parameters alpha and lambda 2. So density function of y is f of y is equal to alpha raised to lambda 2 gamma lambda 2 e raised to minus alpha y raised to lambda 2 minus 1 where y greater than 0 and parameters alpha lambda 2 greater than 0 and 0 otherwise. Okay, so these are the PDF of x and y. Further we have given that x and y are independent. So joint density function of x and y is f of xy is equal to f of x into f of y. Since we have given that x and y are independent. Okay. Now, so your joint density function is written as f of xy is equal to f of x is your alpha raised to lambda 1 gamma lambda 1 e raised to minus alpha x raised to lambda 1 minus 1 into alpha raised to lambda 2 gamma lambda 2. Okay, e raised to minus alpha y raised to lambda 2 minus 1. So that means which is alpha raised to lambda 1 plus lambda 2 gamma lambda 1 into gamma lambda 2 e raised to minus alpha this minus alpha x and minus alpha y. So this is alpha is common, only x plus y is there and x raised to lambda 1 minus 1 y raised to lambda 2 minus 1. Okay, so here we have given that we have given that u is equal to x upon x plus y and we assume that v is equal to x plus y. So that means your x is equal to u into v and y is equal to v minus u. Okay. So here we have taken common v minus v, so only 1 minus u is there. So y is equal to v into 1 minus u. Now further we find the Jacobian, that is Jacobian is equal to del by x by del by u, new variable with old variable with respect to new variable, del by x by del by v, del by y by del by u, del by y by del by v. So which is equal to your x with respect to u is v, x with respect to v is u, y with respect to u is minus v, and y with respect to u is 1 minus u, that is v into 1 minus u minus minus plus u into v. So that means v minus u into v plus u into v, so that is equal to v. Okay. So your v is x plus y. So x is positive, y is positive, so v is also positive. So absolute value of Jacobian is, absolute value of v is nothing but v, since v is positive. Okay. And if you have to find the range of x and y here, we know that x is greater than 0 and y is greater than 0. So ultimately v is also greater than 0, and the range of u, we will find it in now. So range of u and v is your u is equal to x upon x plus y. We know that x is positive, x plus y is positive, so that means this quantity is positive. Also we know that if x is greater than 0, x plus y is also greater than 0, so that means we can say that x is less than x plus y. If x is less than x plus y, then x upon x plus y is less than 1. So your this quantity is 0 less than u less than 1. This is the range of u. Okay. But your y is, what is the y? Y is v into 1 minus u, and this quantity is greater than 0. That means we can write it as v minus u into v is greater than 0. So v is greater than u into v. Okay. So here v is greater than 0 and 1 minus u is also greater than 0. So you can write it as 1 is greater than u. Also here we get the 1 is greater than u. Okay. So ultimately your result is getting कि u is lies between 0 to 1 and v is just greater than 0. So this is the range of u and v. Okay. So now the joint PDF of u into v is your g of u into v is equal to your f of xy joint PDF of x into y, where x is equal to u into v and y is equal to v into 1 minus u and your Jacobian. So that means your density function, joint density function is alpha raised to lambda 1 plus lambda 2 divided by gamma lambda 1 gamma lambda 2. Okay, e raised to minus alpha, your x plus 1. So x plus y is v. X is your u into v raised to lambda 1 minus 1. E raised to v raised to your y raised to lambda 2 minus 1. Y is v into 1 minus u raised to lambda 2 minus 1. And your Jacobian is v, simple. So if I have simplified it, alpha raised to lambda 1 plus lambda 2. Here I have multiply and divide the gamma lambda 1 plus lambda 2. Here gamma lambda 1 plus lambda 2 divided by gamma lambda 1 into gamma lambda 2. E raised to minus alpha is there, v is there. I have separate out terms of v and terms of u. So v raised to lambda 1 minus 1 and plus lambda 2 minus 1 and this plus 1 is there into u raised to lambda 1 minus 1 and 1 minus u raised to lambda 2 minus 1. These are the equations of joint PDF. So I have separate out it as alpha raised to lambda 1 plus lambda 2 gamma lambda 1 plus lambda 2 e raised to minus alpha v raised to lambda 1 plus lambda 2 minus 1. This is your gamma lambda 1 plus lambda 2 into upon gamma lambda 1 into gamma lambda 2. We can write it as beta lambda 1 lambda 2 u raised to lambda 1 minus 1 1 minus u raised to lambda 2 minus 1, where u is lies between 0 to 1 and v is greater than. This is the joint PDF of u and v. Now our interest to find the PDF of u. So that is g1 of u is equal to integration over v g of u comma v dv. That is v is your 0 to infinity. V is your 0 to infinity, and your joint PDF is alpha raised to lambda 1 plus lambda 2 upon gamma lambda 1 plus lambda 2 e raised to minus alpha v raised to lambda 1 plus lambda 2 minus 1 into 1 upon beta lambda 1 lambda 2 e raised to minus u raised to lambda 1 minus 1 and 1 minus u raised to lambda 2 minus 1 into dv. So I have taken the terms which is independent of v outside the integral sign. So that is 1 upon beta lambda 1 lambda 2 u raised to lambda 1 minus 1 1 minus u raised to lambda 2 minus 1 alpha raised to lambda 1 plus lambda 2 upon gamma lambda 1 plus lambda 2. Integration over 0 to infinity e raised to minus alpha v raised to lambda 1 plus lambda 2 minus 1 into dv. We know that the result of gamma function is integration over 0 to infinity e raised to minus ax x raised to n minus 1 dx is nothing but gamma n upon a raised to n. So here n is equal to lambda 1 plus lambda 2 and a is equal to alpha. So if I have to put here, so we get this integration as alpha raised to this integration is 1 upon alpha raised to lambda 1 plus lambda 2 multiply by gamma lambda 1 plus lambda 2. So these get cancelled with this. So we get only the terms are 1 upon beta lambda 1 lambda 2 u raised to lambda 1 minus 1 1 minus u raised to lambda 2 minus 1, where u is lies between 0 to 1. So which is the PDF of beta distribution of first kind with parameter lambda 1 and lambda 2. So therefore u is equal to x upon x plus y has distribution beta first kind with parameter lambda 1 and lambda 2, where x has a gamma distribution with parameter alpha and lambda 1, y has a distribution gamma alpha lambda 2. Both x and y are independent. Then your x upon x plus y is beta first kind with parameter lambda 1 and lambda 2. Okay, so thank you so much.